Hello, and I'd like to talk about the constant source diffusion model in MATLAB code. Kevin gave us the finite difference equation, so we need to represent it in MATLAB. Let's see the MATLAB code first. Initially, we set two one-dimensional arrays. First is points and second points new their arrays, and 1 multiplied by 100, and then we set the back concentration equals to 2e19, and we set time interval equals 100. You can change it anyway, and set the constant. This constant equals this equation, but in this special situation we just need to equal 0.5, and there is two loops of it. One is the internal loops, and it's a big loop. To get the continuous results, and the internal loop we need to use it to calculate every point's concentration. So we set the back concentration to 2e19, and we use this finite difference equation, and we get a new value from the old value. So we set the loops, and we plot it one by one, and let's see its conclusion. So this is the increasing time. You can see that until 100 time. Okay, so let's see the principle of it. So in the first iteration, I don't stop it. This is the 200 times. So in the first iteration, we borrow 0 to get it work, because we don't know the next status concentration, so we assume that it's 0. And I stopped to the first iteration, and I get this graph. So this graph shows the first atom go to the deepest ground in one dimensional. For example, so the constant source concentration is 2e19. So the next status should be 2 plus 0 divided by 2, 1, and then 0.5, 0.25. So this is the first iteration. Jump into next point, etc. This is initialize of this model. And the second step, I don't capture the curve, but the number is number should be here. So the number should be 2 add by 0.5 divided by 2, it's 1.25, because this is the T2. So the second time I want to calculate this point concentration, so we need to use the previous status add by next status previous time to get it, and then we need to get it as well. Use the previous status and then next status, and then so this is the second iteration. What can we see in sequence? You can see the second point increasing, and this is the definition of the constant source diffusion as well, because the inventory, each point has the same concentration in this room, in this model. So we just verify it by increasing of the second point. So I try to get more and more iteration, and the second point concentration should be increasing and around to 2e19. So this is a table to show that. So this is the first iteration, and this is the T0 and 0.0. The concentration is 2. T1, its constant source shows that there is constant in 0.0, always 2e19. That is the principle of constant source diffusion. Thanks.